This is TMUA 2021, Paper 2, Question 7. We have a circle with equation x minus 9 all squared plus y plus 2 all squared is equal to 4, and a square with vertices at 1, 0, 1, 2, minus 1, 2, and minus 1, 0. And a straight line bisects the area of the circle and the square, and we want to work out the possible x-coordinate where the x-intercept of this line. So what does it mean for a straight line to bisect the area? Well, that means it divides the area into two. And so what property must this line have? Well, it precisely must go through the centre of the circle and our square. Why is that? Well, let's do the case of the square first. So if I draw a line, a square, and a line going through the centre of the square, does this line bisect the area? Well, if you draw this dotted line going vertically up, we have this pink region and this green region. And by symmetry, this pink area is equal to the green area. And if you look at the original line, we know that from the original vertical line, this red line is now covering this extra green region, but foregoing this pink region. So they cancel each other out. So indeed, any line through the centre is an area bisector. But now, can a line not going through the centre be an area bisector? So let's consider this example. Well, this obviously doesn't look true, but how can you prove this generally? So if you've got a line not going through the centre, what can you do? Well, you can just move this sideways to a line that does go through centre. And by moving it, we're like redistributing the area on the left-hand side of the line to the right-hand side of the line. So, but we know that this green line does bisect it, and therefore this pink line can't bisect it. Therefore, all area bisectors must go through the centre of the square, and we can do the same thing for a circle. So now we know that this straight line must go through the centres, and that uniquely determines our straight line, as there's only one line going through 2 points. So now, once we have the location of the centres of our circle and square, we can work out our line. So we know the centre of our circle is going to be precisely 9 and minus 2. And what is the centre of our square? Well, sketching the square, we know it has vertices at minus 1 at these points here. And visually, you know that the centre of the square is going to be at 0, 1. So now let's work out the equation of our line. So the gradient is going to be change in y over change in x. It's going to be minus 2 minus 1 all over 9 minus 0, which gives us minus the third. So because y is mx plus c, the c is going to be our y-intercept, which is precisely going to be 1. So the equation of our line is y is equal to minus x over 3 plus 1. And now we want the x-intercept, which is precisely going to be when this is equal to 0, i.e. x is 3, and so our answer is B.